Okay, we're live. Welcome to episode 40. Larry, we've made it to 40. Can you believe it? Episode 40 of Turf Chat. I want to thank everybody for joining us here today. We've got, I think, a special treat. I think less PowerPoint and more hands-on demonstration with Brad Jakubowski, who's an instructor at Penn State, and he's joining us from his makeshift lab of irrigation in his garage. And also joining us is Larry Stoll with Pace Turf. Larry, why don't you tell everybody, say hi and tell everybody about yourself.
Oh, well, I'm just a consultant and out in San Diego and work with paceturf.org. You might have heard about us. I don't know.
Nah, everybody's heard about you, Larry. And Brad, why don't you do a little bit of an introduction on yourself?
Greetings. Name's Brad Jakubowski, and like John had said, I am an instructor out at Penn State. I teach 4 different irrigation classes out there. And this semester, I've been in the process of building a brand new online irrigation course. And I think Charlie's out there. So Charlie's been kind of cutting his teeth with us as we're doing that. So it's been a good adventure, and we're trying our best to incorporate as much hands-on or practical kind of information that we can with an online class. And so we're going to kind of cover some of those things as well today.
Awesome. Yeah, I think that a lot of people have been following your Facebook posts and tweets out there, and I know I've been very impressed, so I'm excited about today. I'll introduce myself. I'm John Kaminsky. I'm a professor at Penn State Turfgrass Science, and started these Turf Chat things many, many years ago with Larry and a few other people in the industry. And now this home quarantine, stay-at-home stuff, we just decided maybe we could, bring it back, and hopefully people will, enjoy it, give them something to do. I will mention, if you're watching this live, there's obviously the opportunity for questions and answers. I'll be monitoring that, and so you can just put it in the chat or put it in the Q&A, and I'll either interrupt and ask Brad, or we'll wait around towards the end. Otherwise, I'm going to go silent, and this will be available on YouTube. So if you lose connection or something happens and you bounce out, you can check the turfdiseases.org website, and we'll have the YouTube link up there for people to view. So with that, Brad, I'm going to turn it over to you. I'm sure I'm going to be fascinated and jump in and interrupt you a few times, because I am not an irrigation guy. So all of this is pretty cool to me. So it's all you.
Thank you, John. Okay, so what we're going to do today is, I guess the title of our meeting today is a little bit on tips, kind of tips on irrigations. And so I thought I'd just kind of go over some of the things that we've been going over in class and trying to do here via distance. And what we're going to do is we're going to kind of start simple on some tips, irrigation tips, whether it be residential, commercial, or as you get into more, I guess, advanced commercial or heavy duty with sports fields and golf. And then we're going to get a little bit more complex and getting into a little bit of troubleshooting. And we're going to kind of get ourselves introduced to one of the golf controllers behind me, just with some basic things to look for, whether it's in a golf controller or if it's just a regular residential commercial controller. What are some things to look for? What are some things to do, or standard operating procedures with some of those. So let's get started with just some simple things. And the first thing I wanted to start with was, not all components are made equally. And what I'm thinking about it with that one there is, if you go to a box store and you're looking, let's say, to buy some little pop-up spray sprinklers for your home, you may have a huge range in prices from $2 a head to $10 a head for the same type of sprinkler. And you're thinking, well, I better just get this, the less expensive one. Well, there are slightly differences in the quality or the toughness of the durability of these different components. And so I thought I'd share that with you. And this is not intended to, I guess, be brand specific. All manufacturers have a full range of, let's say, low, medium, high, or let's say top shelf, middle shelf, and kind of lower shelf components, just kind of based on price point. So I thought I'd just kind of share some of these with you to show you just some of the basic differences, or what things aren't made equally when we're looking at these. So let's look at, I'm going to switch my cameras here real quick and go from there. All right, so hopefully you've got a little white pad there. So what we're going to look at first is a little pop-up spray sprinkler. And this is a basic spray sprinkler, and with it normally comes a spring, and you've got your riser, here. Hopefully that's kind of coming in and out of focus. We'll see how that works with us there. There's your riser. Your bodies are fairly consistent with that. And then you've got your cap and your wiper seal. This wiper seal has flexible plastic in here, and it's made up of kind of a plastic and rubber composite in here. And as water then flows up through these, because then what happens when you turn an irrigation system on, this riser is rising up through this here. And so then there's water flowing up in between there and pushes, actually there's a little space here, and the wiper seal expands, keeping that sealed, so it allows this riser to fully engage and with little or no water leakage whatsoever. And as you can see, this one, the cap and the wiper seal are molded all together. So we have, it's a relatively simple one, and so this would be possibly like a relatively inexpensive pop-up spray sprinkler. Okay, so that's the first one. So I'm going to leave some of these parts nearby so we can kind of take a look at how these differ as we go up through. So as we're working our way up through price point, then we have this one. Here's our cap, and then it also has, with this one here, has its own wiper seal. And the nice thing about this, it's got that same working technology here. Okay, so this is going to expand, this little piece is going to expand right in there as this riser is coming up through there. But the nice thing about it is as these age and become, a little bit more brittle or a little harder, sometimes that rubber doesn't quite flex as much. So then you can actually go in and replace these without having to replace the entire head. And so so here's your cap and your wiper seal, and then here's your spring. And then you've got just your plain old riser right here. Okay, so you've got that. So these are some of the difference. So there's some similarities there and a little bit of a difference. However, all of a sudden, if you look at this here, you can all of a sudden start to see a little bit of a difference in the spring. Okay, so this one's going to have a little bit more powerful retraction, or a power of retraction to be able to retract this riser back down in the head. These springs are used for when the water shuts off, it retracts that riser back down into the body. And so as you can see, there's a pretty significant difference in the length, and sometimes even in the thickness of the wire, or the spring wire there. They make quite a bit of a difference. And so there are some differences there when you're looking at sprinklers, and this can be done. You'll see similarities like this with your spray heads that we're looking at here, or if you were looking at the more heavy duty rotors, there are also those same differences among those sprinklers there. So there's these two. Okay, and so we'll lay these to the side, and then finally we will get to this one here. So then here's our cap, here's our wiper seal, and then here's our spring on this one. And all of a sudden you can even see the differences here. You could definitely see a difference in spring strength and spring size. And I had one of the students the other day mention, it's like, well, is that much of a difference between these two? And actually, of course, so what I had to do the other day then was do a test and see which one would shoot the wiper seal the farthest. And so on average, so out here in the driveway, I was, basically just playing around out there in the driveway, these springs would launch this wiper seal about an average of 6 to 12 feet farther than this one. And this one barely made it hardly, nearly as far as well. So there is some different strengths in these. And so these longer springs like this are definitely going to give you an opportunity to have that retract back into there very well. Okay, the body is pretty much the same. And now what we can see here with this one is that there is also, you can't see through the bottom of this one. And so with this, there's also some added technologies that they've included with this particular sprinkler. Now, this particular head is what they call it's pressure regulated at 40 PSI. And what that looks like then would be, here is a kind of a clear shot of that riser. And you can kind of see, this is like the ones that we've been looking at, straight through. There's nothing in there to regulate water flow or pressure or anything else like that. So this one is just kind of your standard run-of-the-mill riser. This one, on the other hand, you can start to see that in there, this is a pressure regulator. And so this pressure regulator then, as the water's flowing in here, is that spring then is regulating how much pressure you can get through there. So you may have incoming 70 PSI coming into the base of this, okay? But it's going to regulate it so that when it's coming out here, it may only be 40 PSI. And most of your spray sprinklers prefer, your spray nozzles prefer to be, their best operation is about 30 to 40 PSI. And especially if you're using the new rotary spray, the multiple stream nozzles, they're required to be operated at 40 PSI. And that's where one of these things would come in handy. Another thing that we see then is this check valve. This little check valve, these can be added or aftermarket, but this check valve then is there to, when the riser then is put back down, or when it retracts back down into the body of the head, body like this, it seats itself in here, not allowing any water then to come back up through here. So if you've got a hill and you've got a sprinkler here, 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 and it's working its way downhill, these check valves then will not allow water to flow back out of the sprinklers. And so oftentimes you might be walking and you see the sprinkler system off, but you see water flowing out of the heads. Well, this check valve saves that water. So it's a very good water saving device. And so these
Brad, I have a question.
Yes.
So obviously you talk about the springs and just the differences there. What's the difference relative in price?
Okay. Oh, good question, John. So your differences in price, then you may have your standard sprinkler, your base sprinkler might be, let's say, $2, $3 per sprinkler, where these here could be anywhere, depending on the market, could be between $5 and $10 per sprinkler. Okay, good question. Okay, any other questions? Okay, so that kind of takes us through a little bit of some basics, some basics with just some basics with sprinklers and some of the things to kind of look for. So there, even if there are differences in prices, there are definitely then some differences then in the robustness of the sprinklers themselves. Okay, all right, moving on to the next part.
Larry had a question, which
Yes.
he can unmute and ask, or I could just ask it. But he said, what's the pressure regulated sprinkler body called? The one that's pressure regulated.
What's the, I guess, just what the name of it is?
Okay, just what do you, if you were going to pick one up, what would you call it? Pressure regulated sprinkler body, or
Yes.
is there a particular name for it? That's it.
So that would be it'd be a pressure regulated sprinkler, spray sprinkler, or a spray sprinkler with pressure regulation.
Yeah, I've got micros around the house here, and it's really hard to get the pressure right with the standard regulators on the system. So that would be a big advance.
And actually, that's a very good
$2 ones, Larry. Is that why?
Oh yeah.
That's a very good observation, Larry. Is that you can get the valves are oftentimes pressure regulated, but then if you can also get these regulated heads like this, makes a huge difference, and your consistency of application become very, very much more uniform.
Well, with the micro emitters, I switched to micro emitters on the standard heads, and it's not as good as I would have hoped.
Excellent. So
we had another question in there
yes.
before you get back at it. Anthony asked, what's average maintenance upkeep per year? I assume in the early parts of this, there's not that much to do, but as they get older, then.
Right. Oh, actually, Anthony, it's a very good question. Average, most of the time, what happens the most often would be the wiper seals start to get a little bit old. And so the risers, so as these sprinklers age, these risers then become more brittle. And so that sprinkler has a tendency to stick. And then all of a sudden you'll start getting debris in here. Rocks and other types of debris will start to create grooves in the risers here. And so they have a tendency to get stuck. And so then they get clipped by mowers, or people walking by have a tendency to want to kick those if they see them sticking up. And so most often, the thing that's going to happen most often is you're going to be replacing the wiper seal on that one there. And if it's a molded one-piece wiper seal like this one, then you may actually then be replacing the entire head, unless you can just get the caps themselves. So excellent question. Very, very good question. Okay, any others? Okay, all right, well, I'm gonna move on to, I guess the next thing would be that not all pipe is made equally. and that's not necessarily a bad thing. It's just that they happen to be different. So let's take a look at some different pipe. Just so if you're looking at different pipes, you'll have some ideas on what's going on here. So we've got some, these are all 1-inch pipe or 1-inch nominal sized pipe, meaning that oftentimes based off of the inside diameter of this pipe, and it was all based off of originally galvanized pipe. So, and this here is Schedule 40 1-inch pipe, and you can see that's kind of the wall thickness there. And so these were initially made to mimic galvanized pipe, and they just happened to make them out of polyvinyl chloride instead of galvanized metal. Okay, and so this is Schedule 40, and this is Class 200. Okay, so you can kind of see a difference in the wall size. And so with PVC pipe, if you're working with this is PVC, this is polyethylene, PE, or this is PPVC, polyethylene pipe. And so the PVC, with this one here, is what they call outside diameter controlled, where when you're working with PVC, the outside diameter has to stay the same. So if they make the wall thicker, it encroaches on the inside. So this way, whether you're working, so here, if this is your fitting, a 1-inch male adapter, it's got to be able to fit on a Class 200 piece of pipe, and it also has to then fit onto a piece of Schedule 40 pipe. So PVC is outside diameter controlled. This stays the same, the inside changes. Now, the interesting thing, when we're working with schedule type of pipe, this is Schedule 40, and so this one here may actually have a pressure rating of about 400 PSI. Class 200 pipe of this size, since it's Class 200, always has a pressure rating of 200 PSI. As this pipe increases in diameter, the wall size stays the same, so the pressure rating decreases. This one, if you're working with 200 class pipe, regardless of the diameter of pipe, okay, the pressure rating always remains the same. So as this increases in diameter, the wall thickness increases, and it's going to increase on the inside and not on the outside, so that you can still continue then to fit your different pipes. So when you're out there looking for pipe, if they say pressure pipe or something like that, and they're referring to that, most oftentimes it's Class 200 pipe, or it's Class 160, or a Class 300, or Class 310, or excuse me, 315. And so if you see a class pipe, it's always, and it's like Class 200, it's 200 PSI rated. This one here, you can kind of see is probably at least double that as far as the pressure rating goes. This one gets bigger in diameter, the pressure rating drops. This one will always remain the same. And so just a couple things that I want to just kind of share with you as far as when you're looking at PVC pipe or shopping for it, those are some of the differences to look for. Okay. All right. Next one is polyethylene pipe. PE pipe is used a little bit more out in the Midwest. A lot of the irrigation systems out there are using this type of pipe, and it's more freeze resistant or resilient. And with this one, instead of it being outside diameter controlled, it's an inside diameter controlled, because whenever you're working with polypipe, polyethylene or polypipe is what they call it, you're always putting your fittings on the inside of the pipe, like so. So it's always fitting on there. So since all your fittings need to be able to fit that, the inside diameter stays the same, but the outside diameter then changes as the pressure ratings change with this one here. Okay, so we had PVC, PE, polyethylene, and then we have one last one that they're using more and more in the golf course industry, is this one here, which is high density polyethylene, or HDPE. Okay, now we switch back to it being, you can kind of see it's fairly hefty. It's got a fairly thick wall. It's high density polyethylene. Okay, and this is what's being used more and more often. And with this one, as you can kind of see, this fitting is fit inside, or this pipe is put inside the fitting here. So then this one is also then outside diameter controlled. And so then the inside diameter is going to change, but the outside diameter will remain the same. Okay, so that's just a little bit about piping. And so I just wanted to share that one with you. And one last thing that I wanted
Before you go on to that, I had a question.
Yes, John.
I always hear people talking, and it sounds like, people will be like, oh, we're going with HDPE, and, yada, yada, yada. It's state of the art. And then I hear other people are like, people are idiots. That's not, so you can always go back with the PVC pipe. And it's, you know, what's the benefit or the negative of any of these?
Oh, good question. So there are positives and negatives to both. One of the selling points right now with HDPE is if you made they claim that if you made or built an irrigation system 100% out of HDPE pipe, if there was some way you could hook onto it with a helicopter, you would be able to pull the entire system up into the air that way, all in one piece. Okay. And it's also, again, it's fairly resistant to, or very resistant to freezing and some of those things. Some of the disadvantages, I suppose, to HDP is in the installation or the construction process, is what you're doing is you're welding or melting pieces together. And when you're doing that, you need to make sure that you have extremely clean surfaces. And normally it means that you're using electricity. So if you're out doing a new construction, HDP goes fairly quickly. But if you're doing a repair and all of a sudden you've got to dig a big hole and it's raining outside or it's muddy, you've got to make sure that you have absolutely a clean mating surface here and a clean mating surface here to make sure that it works. So then all of a sudden you're out there cleaning it up. You've got to clean it off with 90% isopropyl alcohol to make sure that there's no oils from your hands on either surface that you're doing. So with new installation, HDP is very good. Repairs are a little bit more of a kind of a challenge than oftentimes with PVC. What you're seeing these days is kind of a hybrid, is where they're using, let's say, large PVC pipe for the main line. So it's like the 12, 14 inch pipe, but then using smaller, like the 2-inch pipe here for laterals and for connecting the heads and everything else like that. So you're seeing some things like that. So there's some, so again, give and take with these. The fittings are a little bit pricey these days, and you'll probably see that decrease over time. And right now, since HDPE is also very popular with, let's say, gas, the gas industry, this is what they use for transporting gas. Sometimes the availability of the different pipes can be a little bit of a challenge. And it also fluctuates quite a bit with fuel prices. So, excellent question. Okay, any others? Okay.
No, that was it. Thank you.
Great. One other thing that I want to do, this is kind of a pet peeve for me anyway, is whether you're working with poly pipe or whether you're working with brass or copper or any kind of pipes, there is the correct way. Oftentimes you may be using Teflon tape, okay? Using Teflon tape to seal your threads. Okay, and so I just wanted to quickly go through this, that when you're applying Teflon tape, there actually is a wrong way and a right way to do that. And so the right way, or the correct way, is so I apologize to my lefties over there, but if you're right-handed, it's always good to have the threads facing to the right, this way, okay? And also then what you want to do is unroll a little bit of your Teflon tape here, put it on the first couple of threads, and the important part is having it on these first few threads here, because rarely do you ever get your threads all the way out to the hilt here. So you want to put that thread tape on the back side here, and you want this to look like a lowercase b or a number 6. It wants to look like this. If it looks like a D, then it's going to be more of a hassle, and you're never going to really have constant pressure, constant pressure on the pipe threads this way. So you always want to have it so you're on the back side of the threads, it looks like a B, and then this way you've got your fingers, you've got constant pressure here, and it's just 1 wrap, 2 wraps, and 3, and you're done. And then you can thread that in, and with your Teflon tape, thread it in all the way until it's hand tight, and then with the channel locks, whatever it is, give it maybe 1 more turn tops, and you should have a good watertight seal. Okay? All right. So that's a little bit about that. So we're going to get into a little bit more complex issue here, or situation. And what we're going to do is we're going to get into a little bit of electrical troubleshooting. This was another one of the things that we went over this semester, was a little bit about troubleshooting. And one of the things that I found out in the industry oftentimes is that your turf managers oftentimes are a little bit unfamiliar with a multimeter and being able to test some of their circuits. Well, they go out to the controller, they click on and nothing happens. And so what we're going to very briefly today is go through a little bit of how this works. And so one of the first things you may do then, especially like when I was in the Air Force, was we would say, okay, power in, power out. Is it turned on? There were times where I'd have pilots, they would come back from a mission and they would report on their post-flight report was this particular system didn't work in the OFF position. Well, we would then try to find some way to very politely say, well, put it to the ON position and see if it would work the next time they go up in their aircraft. So that stuff happens. So first thing is then is power in, power out, or water in, water out. Is the water turned on? Is the power turned on? For the 2-year students a couple of years ago, we had a practical final, and I was watching one of the students. He had everything hooked up beautifully and kept trying to turn it on, but then he didn't realize that he didn't have the water turned on, so the valves didn't fire up. So then once he figured that out, then he was able to just finish up very quickly. So, all right, so one of the things that you would normally do then is when we're checking this is you're going to check continuity for a particular circuit. And so what happens when you're checking continuity, you want to find out, do you have a signal coming through, let's say for this particular valve here, you want a continuous circuit coming through here, through the solenoid with which activates the valve, coming back through here and returning back to here. When you use a multimeter and you're checking for ohms, there's a little battery in there, so it's sending its own signal, and so it's looking for resistance. Well, the solenoid is what has resistance. And with these, it's somewhere between, let's say, 20 and 60 ohms. Okay, and that's a value for resistance. So let's take a look. So we're going to test this first one here and see what happens. So here's our circuit. So we're going to put it on here. I usually put the black on the return common white wire, and this one here is on our control wire. And we're seeing that, aha, we've got 27.2 volts. And for this particular solenoid, that's correct. Most of your solenoids, if it's working correctly, has a resistance of about 20 to 60 ohms. So this one's good. We go to the next one. This circuit, we're checking the yellow circuit. Okay, again, 28 ohms, good. We go to this one. We've got 0 ohms telling us there's no resistance there, which tells us then that there is a short and there's no resistance. So unfortunately, that green circuit has a short in it, and we need to figure out what's causing that short. Okay, that maybe there's a couple of wires that are crossed or got stuck together, or there's water or something like that got in there that caused a short. And then this last one, we go over here, check, and it gives us just a 1 like this. Well, that 1 then is telling us that it's an open, and that it has, if you ever see a 1 like this, okay, like that, that's telling you that there's infinite resistance, that there's so much resistance there that it's just infinite, and telling us that there's an open there, that the wire is probably cut or something to that effect is what we're looking at. So you've got, this one's good. Okay, about 28, they're about 27, 28 ohms. Keep that in mind as we go to these next 2 other things here. This one here, this one's good, this one's a short, and this one is an open. Okay, so that's our first one we're going to take a look at. Briefly, we're going to take a look at a couple other ones here. Okay, this next one. Oftentimes what we may do then is out either on a golf course or out in a particular area, we might, let's say if we added a head somewhere, and you've got to be able to then run those wires somewhere. So oftentimes what they'll do is they say, you know, instead of running a wire all the way back from this head all the way to the controller, let's just wire it up to that head that's already sitting there. And so when you do that, all of a sudden you may have 2 heads operating at the same time. Okay. Well, one way to hook it up would be in a series circuit. So everything we've got, these heads here, we've got this valve and this valve both hooked up. Okay. And they're all wired up to this one here. Well, this is what we call a series circuit. It's a series circuit. It's continuous over here. It's going through the solenoid over here. It's coming up over here, back down through this solenoid, back to here. So it's a series circuit. And if you have a series circuit, if we were checking the circuits again, what would we see is all of a sudden we're at about 56 ohms instead of 28 ohms. So what it is, it adds them up. So it's additive. So when you're looking at it, so if you are checking your circuits and you see something that's looks double to what we had, then you're like, well, that's interesting. Maybe those things are hooked up in a serial circuit. And normally, if you're going to add a head, you don't necessarily want it hooked in series. You want to be able to have it hooked in parallel, and that's the next thing that we're going to look at. Okay, so that's this one here. And then the next one, I'll bring this one in here. And actually, we had a student Actually, just this last week, we were talking about this in class. Okay, and so here we were back again. And so with a parallel circuit, you can kind of see what we've done then is that the leads, we have one lead from this valve and one lead from this solenoid and one lead from this way. They're wired together. And then you have a lead and a lead from this solenoid. They're wired together. One of those goes back to here, and then one of them comes up here. That's what you would call a parallel circuit. It's kind of, they're running in parallel together this way. Okay, now let's see what kind of result we get with this one. And so what do we see? All of a sudden, what we're seeing is it's about half of what one of those readings were. So every time you add another one in parallel, you're cutting the, you're reducing the resistance, based on that. So then if we have two hooked in parallel, you're going to cut the resistance in half. If we had 3 of them hooked in parallel, it would cut it to 1/3. And this is where us old stereo buffs, oftentimes we would blow our speakers, because if we had a whole bunch wired together and put them in the back of the amplifier, what we're doing is we get more sound, but you're reducing the resistance of those speakers, and they're much more apt to blow. So if you do have heads out there in the field like this, and they're hooked up this way, then they could be, actually, since they have less resistance, could be more susceptible to a lightning strike or some kind of a power surge. So it's nice, it's convenient to be able to just wire them up to another head, but there are caveats or challenges to that. So just a little kind of a brief thing about just some troubleshooting and some of the things that we would look at when you're trying to figure out if you've got something going on with your electrical system. Okay, all right. So are there any questions about that? Otherwise, we're going to move behind us and take a look at the control panel behind us. And I'm going to go ahead and switch this. So we're going to be looking back here. And so I'm going to, hopefully if I can do this successfully. Yeah. Oh, yes, Larry.
Yeah, I got a question. So when
Yes,
when they wire up a bunch of heads in a block system, so you flip the switch like you're just doing with multiple heads on one control panel, would they normally wire those up in series or parallel or separate, all separate?
Actually, interesting, a good question. So actually what you would do is, these would be kind of in a block. Let me switch back over to there, to here. And these would actually be considered, let's say, this would be block number 1, block number 2, 3, and 4. And so each one of these valves may control, let's say this one controls a half dozen sprinklers, this one, and this one. And so this would actually be a valve manifold for multiple sprinklers. So excellent question.
Okay.
Excellent. Okay, oops, there we go, good. All right, so I'm gonna see if I can switch over to my phone and have us take a look at a few things over here behind us, okay? Sorry. Thanks, John. And I will switch out of this one, I'll stop that one, and I'll go over to here, and oh, good. Okay, so I'm gonna pick up my phone briefly here, and we're gonna take a look at a few things. Sorry. Okay. All right. Can you guys hear me okay?
Yeah, that was my fault. But basically what's going to happen is if you put your phone, and that's what we're going to want to see, but the sound's not coming through that, then it will, it won't show up for the people that watch it later. But what you could do is you can mute your microphone on your laptop and then just unmute so that no sound's coming out of it, and then unmute your phone. That probably would work. Does that make sense?
Okay. Oh.
Yeah, I don't know where the sound's coming out of, whether it's your laptop or your phone, but that might help. If not, it's fine. For the live people watching, they'll be able to get it. The others will just get a talking head, and they won't see what you're looking at. Just a reminder, we've got about 15 minutes left. And you're muted on both, so I don't know if you're talking or not.
Okay. How about now? Can you hear me okay?
Yes, yeah, sorry, I can hear you.
Okay. Oh, sorry. Okay, so what I wanted to look at real quick here was some different types of things to look for, whether they're on a golf controller like this or on a home or more of a residential commercial controller. So what we're looking at here is some of the different general things or general functions that are similar throughout. Let's say if you were if you were working with a new controller or one that's unfamiliar with you and you needed to figure out where to put, let's say, that common white wire, one of the best things to look for is just at least just look to see where that screw head, which screw head then is actually been stripped out or almost stripped out or been used the most. Like this one here has been used quite a bit. So that would definitely clue you in for that being used more often than these COM wires down here, which have not been used at all. So if anything, just looking at screws, kind of seeing which ones are a little bit more stripped out would be very beneficial. So that's one thing to kind of look for. Now let's go ahead and let's fire this one up. And so like with this one, again, if you're trying to figure out you fired up something from the central control and nothing happened, is well, come out here and look for the lights and see what you've got. And so what I've got here is this is the power indicator for 5-volt control. The 5 volts is going to be kind of working with the internals of this particular system within the circuitry here. This one here is the 28-volt power indicator, which is then telling us that we have power that's available to send a signal then to the solenoids that are controlling the heads themselves. So this is like internal power. This is kind of like external power. Another thing to look for then is this one here is something like this. This is also going to be kind of an indicator for that as well. Now, one of the things that I wanted to show you with this one here is I've got, whenever possible, I've got these wires coiled up and I've got these wires coiled up. Oftentimes you'll see the manufacturers recommend coil them if possible. And as you can see, here's a coil, okay? And actually all of these right here are in their own sense, but since they're integrated circuits, are also coiled. Anytime that you can coil a wire like this, it's going to create an induction coil. That induction coil then it kind of resists power surges. And so in this case here, if you had, let's say if you got, if you're prone to lots of lightning strikes and you're having just fits with some of those things, you might want to try, if you can, if you've got enough wire, is to coil these to help protect yourself from lightning strikes or from power surges.
Hey, Brad, let me interrupt you for 1 second because everybody's probably got you in speaker view and they're not seeing what you're doing. But just for the people that are participating here, if you take it off of speaker view and just put it into gallery view, you should be able to see his camera even though you're hearing him speak on a different channel. So that's what I've done. I think when this is recorded, Brad, it's going to end up being that all we do is see your face and we won't see what you're doing. It's fine. It's just that the sound would have to go through the phone, but we were getting too much feedback. So
what do I need to do then?
Nothing. I just gave everybody some advice. Just keep going on. I think if they go to gallery view in the top right as opposed to speaker view, they'll be able to see what you're showing.
All right.
Thanks.
Okay. All right. So those are some of the things to look at. Also, when wiring up a controller, it's always important then to put, when you're wiring something up, you're connecting wires to controller, always put your wires on the left side of the screw. Left side of the screw. Always want to have them on the left side of a screw there. And the reason is, and this just kind of just some basic fundamentals, is just when you insert that wire there and as you turn it and as you screw that screw back in, what it's going to do, it's going to have a tendency then to want to pull that connector up into the terminal instead of pushing it away from the terminal. So whether you're doing it here, or let's say if you're rewiring an extension cord or whatever it is you got at home, always try to come in from the left side so that when you tighten them up, the wires will always then kind of self-tighten themselves. So those would be some of the things to kind of keep an eye on there. Also, one of the things I also wanted to kind of touch base with, if you're working with controllers, something like this, you get a lot of temperature fluctuations. And one of the things that we had to do with our aircraft was we would look for chip creep. Chip creep, since we have, hot and cold and different things going on with aircraft and even with these within a controller like this, these have a tendency to maybe, let's say, creep. So it's oftentimes it may be good if you're having intermittent problems with a particular set or whatever it is, kind of press on these and see if you get a little bit of a creep or whatever like that, or a click or some kind of a crack. These can, at least if you press these back in, these different chips, things like that, that might actually help you I guess, get a new connection or a better connection again with some of those things there, okay? So those are just some of the different things. Also, this is an 8-station an 8-station output module. So is this one here, and so these are interchangeable. You kind of see they're a little bit different, but they still work really well. Okay, so those were just a couple of things I wanted to share with you there. Now there's just one last thing that I wanted to share. Swip back over here. All right, so here we are. Brad, working with the unions, take 2. Okay,
Yeah,
so one of the best things to do then is if you're ever installing a valve manifold or a series of valves, and there's some things where you may have a whole bunch of these, and sometimes they're packed fairly tight together, and if they're packed really tight together, to be able to spin these off can be really, really just annoying, and it's awful. So the best thing to do then is take an extra investment with these. These are about, this is what you call either a 3-piece coupling or what they would call a union, and they're about anywhere between $5 and $10 a piece. The nice thing about these is that it makes being able to uninstall a valve wonderful. So this way, all you have to do again is just go in, and since these unions have those, they have rubber O-rings in there, you can almost get them just tightened up with hand tight and then just an extra turn with a channel locks, something like that. You could do this one here, and then undo this here, like so. And from here, pop this off. You can go then make your repairs, take this back to the shop, maybe even put one back in really, really quickly, and then troubleshoot that later on. But then within less than 20 minutes, you're back up and running with this particular head, because chances are you wouldn't even have to rewire this if you're using the same type of control valves. All you would have to do is just unscrew that solenoid, pop in a new valve, screw the solenoid back in, pop this in back like so, get this connected, and your downtime is like nothing. And so then all of a sudden here, this picks up there, this one picks up here, you're connected to here, like so, and you're done. So whether you have it hooked up like this, or you've got them coming up out of the bottom, you could do the same thing here with this, is all of a sudden you could also do it if you had a series of angle valves. You could also do it this way. Have one connected here, one connected there, undo this, undo that, pop it out, maybe replace it with one of these really, really quick, take the other one back to the shop, repair it, save it for another time, and you're back, and your downtime is so limited. It's just wonderful. So I highly recommend keeping these on stock, or start using these if you have a bunch of these kind of control valves, or if you've got manifolds. Anytime that you can use these, they're very, very beneficial. And I've had really good luck with long-term seals on these. They seem to work pretty darn well. So very, very, very effective, and very they might, again, the initial cost might be a little bit higher for you per valve, but the labor savings is just amazing. Okay.
Awesome. That was good. Can you do me a favor? I think we're going to wrap up and we want to get some questions. Can you just pan around and show us the setup you got there for all your teaching that you've been doing?
Oh, sure. Okay. So this is kind of my shop. And so right now I've got, there's where I keep all my irrigation parts. I've got my golf controllers over here. I try to put together a manifold here that if we're working on valves or we're doing a little valve class, then I've got a bunch of different valves hooked up there. So then we've got some things highlighted so we can kind of see what's going on with that. This is a little bit more of my extra tools. I also then have these. I got kind of like, they're like temporary walls that we can use and kind of move these around. So if we wanted to actually hook them up to water, you can just move. All I would have to do is just move one of these panels and do that. So we can do this here. Also then, if we're going to be doing some troubleshooting, we can also then use this. And actually, John's assistant, Tim, had actually built this one. And so I was able to steal this from him, and actually he gave it to me to use it for troubleshooting. And it's been really, really nice to work with. And so
this is kind of where my shop has been so far this year. It's been kind of fun. So quite the commute isn't too bad, and it works out pretty well.
It looks awesome. We have a question in here, and I'm sure we're going to probably have more questions. So if you do have a question, don't forget just to put it in the chat or the Q&A. So someone says, say that you're going to have a brand new athletic field, and let's call it a high-end athletic field. I don't know what the difference is, but
Okay.
what recommendation for irrigation heads do you think that they would be for them?
If you can afford them, I like a larger head. Especially like for the outfield or for a football field, and if you've got the flow that would be good for it. The Hunter I-40 ONs, which means they're an opposable nozzle head, they're really hard to beat. Those are good. The other manufacturers also have some pretty good heads, but that one there is a really good one to be able to utilize. So check it out.
How much are Hunter heads used on golf courses?
Not as much. You'll see them some, and the crazy thing is Hunter actually pioneered the access from the top of the heads. Because like now you've got like the Toro, they've got the new Infinity heads, but actually Hunter had actually kind of pioneered that a while ago to be able to get to the solenoid and all of the control parts of it without having to dig it out. And so you'll see them somewhat, at least maybe around here we don't, but I suppose near home, because like San Diego is home for Hunter. I imagine there's probably a much larger market out there that are using the Hunter golf heads. But it's still more of a Toro and a Rainbird. At least out here, it's more Toro and Rainbird.
Yeah, they're not a lot of them for full course installs, but I think they have a lot of specialty heads like their PGP line of heads that are used around specialty areas where you got landscape around greens and stuff. They work really well. A lot of them are used for that.
Brad, how many, well, you have another question. I won't ask them all. Let the students and anybody else in there says, can you explain the pros and cons of the wireless irrigation system or the wireless irrigation control valves? Also, where do you see the direction in this going?
We're seeing some really good stuff with the wireless control. They're getting better with the Wi-Fi portion of them, as far as you getting repeaters, if you need repeaters out there, and being able to use those. So we're really seeing those ramp up. And if you can actually get yourself set up with those, it's not a bad way to go, especially like with any of the brands, Hunter, Toro, Rainbird. They're starting to come up with some really good wireless soil sensors that can be buried, around 3 inches into the ground, and they will still communicate via wireless, which is really, really handy. And so being able to really pinpoint and dial those things in is making a big difference. So wireless, I wouldn't be afraid of it. And it's just going to continue to become more and more efficient and better. And if we can actually then start doing if we can do a deep tine aerification, not have to worry about cutting into pipe or into, or into some wiring somewhere, it makes a huge difference.
What do you need in terms of communication? Did you just have to have communication spots pulled up all over the course if it's all wireless?
Yes, some of those are. So there's some differences with that one there. Some of it's Wi-Fi. Some of you can actually kind of do off of cell phone towers. So there's a little bit of both on that one there. With that one there, as far as being communicating on that. And normally then you'll have a central control back at the shop or back at the office.
Gotcha. Larry, what are the biggest things that you see out in California? I mean, obviously water quality and water availability are probably the two biggest things, but do most golf courses out there have really good irrigation techs that know how to troubleshoot and handle all of these kinds of questions? Or,
well, I think they're pretty good because it's a year-round problem. So it's pretty good, but there's a lot of problems. There's a lot of need for improvement and fine tuning. And then there's just basic problems with circular irrigation patterns. When you're running along, long strips like fairways, it's just inherently the wrong shape to throw water. So there's a lot of work to be done. And I think it just runs every one of those areas. I mean, just the performance of the systems, the original spec, the design, the installation, the maintenance, and it's.
I just keep thinking about the labor part of it and how like having a mechanic is so important, right? Like it seems like having a really good irrigation tech
Yes.
would
Yeah,
be
it's
something that would be critical. Yeah. Especially out in your area.
Yeah, highly valued.
Yeah.
I know at the courses that we had, you had you had the superintendent, you had an assistant, and then you had the mechanic or the equipment manager, and then an irrigation tech. And you would see superintendents and assistants kind of come and go. Someone would get let go, but they always kept the equipment manager and the irrigation tech.
Well, just programming the systems now is a major chore, to get the programming done, and then not to lose that programming, and then to keep it up to date. I mean, it's probably the most sophisticated component of management is in the irrigation system as far as tech involved.
Yeah, and tech, and I think also just institutional knowledge. I mean, and they know where every quick coupler is, every snap valve, every head, every dry spot, every area that's going to be a problem. And it's not just like, an intern that can learn where the hot spots are on a putting green in the summer. You're talking about managing, 18 holes plus. So, yeah. Well, we're about at the time, Brad. I mean, we got somebody saying something in chat. Let me see.
I think I'm going to have to take off, unfortunately.
Larry, thank you very much. I appreciate you,
right.
you jumping
Very
in
good,
here.
Brad.
Thanks.
Awesome work. Love it. I learned some stuff.
I learned everything you said was I learned.
All right. Thank you.
See you, Larry.
Bye-bye.
Brad, in wrapping up, any last thoughts for the people in here in terms of if there's one or two things that they could take home, what would be the important things?
Actually, it was Anthony had actually had kind of alluded to that just here in a comment just a little bit ago. Was he said like the maps and the design that you have can be a real surprise. Having a good as-built is huge, and having an as-built as far as it was designed a certain way, but then if you can actually have a map of wires run can be huge. And what I strongly recommend, no matter what kind of facility it is, if you can get a poster-sized as-built, have it laminated or put it under glass and have it in the break room. And this way, while anybody's just driving, they're taking a cart down number 1 fairway and they see some dry spots, all they can do then is come back. Is when they get back to the break room, is then with a dry erase marker or a vis-a-vis marker, whatever, is mark it on that as-built there. It's like, this is where I'm seeing problems. And throughout the day, as other people come in and start marking things, this is what I saw here. We've got a bad sprinkler here. We got weeds over here. We've got disease. I see some mycelium over here. You can mark them on that as-built, and it's something that everybody can see, and then just it just makes a huge difference. And it's a large communication savings device, and it's relatively low tech. So as-built or just a good map of the course or the facility is huge.
Awesome. So just to give you a shout out and a plug, you're obviously doing this from your home this semester, but you do this hands-on in one of the greenhouses on campus when you have the class in normal times, correct?
Yep.
So that's good. I think you've really taken the irrigation class to another level, and we appreciate that. So with that, I'm going to bail out. If anybody has any last-minute questions, you can put them in there, and we can answer them. Either now or we can shoot you an email. Reminder, this will be online. I think I'll probably have to go in and edit the video to cut out the silent part in the middle, but you recovered well in terms of getting the cell phone to work. So everybody says thank you, and I appreciate you being on too. So with that, we'll wrap it up. This is episode 40 of Turf Chat. You'll find us on turfdiseases.org, and look forward to more of these coming in the future.
Excellent. Thank you, John. Thank you, everybody. And I appreciate your patience on the technology. Or my technology.
It worked out perfect. Thanks. All right. Signing off.
Thanks.